Hi friends, welcome back to More Math with Ms. Beck. Today we're going to be focusing on the angles in a triangle. Let's tap into some prior knowledge. If you recall, a straight line measures 180 degrees. It's a hard concept to know because a straight line looks like it has 0 degrees. However, if you remember using a protractor from one end of the protractor to the other, it's 180 degrees. So a line measures 180 degrees. Having some angles on the straight line makes that 180 degrees or even any degree on that line come alive. Here's some angles on a straight line. The sum of those angles always is 180 degrees. There are 3 angles on this line. This one that measures 75 degrees, the one in the middle that we do not know, and this angle here that measures 45 degrees. If you add 75 and 45 together, then subtract from the whole 180 degrees, you'll get the measure of this angle here. Take a look at this problem. We've been seeing lots of these lately. If we took away lines PR and PQ, you can easily see what this looks like inside a triangle. We have our straight line RQ there. And we have the angles RSP on the line. And we have another angle QSP on this line. So this angle plus this angle must measure 180 degrees. The middle letter of the angle's name always marks the vertex. So in the angle RSP, the S is the vertex or the angle that we're measuring. RSP. This is the angle at S. Likewise, QSP. If we start at Q and go to S to P, the S is the angle, the middle, the vertex that we're measuring and naming. Don't forget, we can name angles other ways as long as the S, the middle, the angle that we're measuring, is the middle letter. We could name angle RSP PSR. And we can also name angle QSP angle PSQ, as long as that S is in the middle. Let's put the lines back so that we can view our shapes. Triangle PRS shows values for 2 of its angles, which are 50 degrees and 60 degrees. Here's triangle PRS. You can easily solve for the third angle using the formula. We add together the 2 angles that we know, 50 and 60, for a sum of 110. Then we subtract that one part together from the whole 180, and we get a measure of 70 for the angle at RSP. 70 is the value for angle RSP or PSR. Again, remember the S is in the middle. Now we can move forward with solving this problem. Don't forget that RQ is a straight line. Since RQ is a straight line, we know it measures 180 degrees. And on that straight line, we have this angle at RSP and this angle at QSP. Because the straight line measures 180 degrees, we subtract the 70 from the 180 and get a measure of 110 for angle QSP. Now we can solve this entire problem. If we add together 110 plus 32, and then subtract it from 180, we can solve this entire problem. Let's try one more problem. We're going to start by analyzing this triangle with the two smaller triangles within it. Pause the video so that you could look for any hints to help you to solve this problem. I see two right angles. Notice the right angle on line DB. Don't forget, DB has a measure of 180 degrees. Right here, there's a right angle which measures 90 degrees. If we subtract that 90 degrees from 180, we get another 90 degrees over here to the left of that line. Now we can solve this triangle by adding these two angles together and subtracting from 180, and we get 62 for that angle at ADC or CDA. Remember, the D is the center letter that names the vertex where that 62-degree value is. I also see a right angle up here, which is 90 degrees. If I subtract the 28 from 90, I get 62. Hence, I have another value for this triangle over here, triangle ABC. Let's see if we could get the value for, what angle are we trying to find, friends? Remember, the middle letter always names a vertex. Try to name it in two ways. We can name this angle here ABC or CBA. If I add 62 and 90 together and subtract from 180, I get an angle measure of 28 degrees, and now my problem is solved. You've done another amazing job trying to solve for angle measures by knowing things about a straight line and knowing how to name angles. Try to lock that into memory today when solving problems. You've got this, friends. Work carefully and slowly, and mostly analyze the problem.